do the Eagle 2022. So there was a feature on this that prevented us from using some of the mold tools in terms of having a little bit of an error with the mirror tool generating the geometry that I use for this part. And so you can see right here, we have this kind of strange artifact that when I mirrored this across, it kind of made a double cut on that face. To fix that issue, what I'm going to do is I'm going to get rid of this mirror and I'm going to replace it with a body mirror that then merges these two bodies together. So I get what I expect to see when I mirror this, where this geometry on this side is reflected accurately on both sides of the part. And that's going to fix some of the issues that I had with the draft on this part as I went to go and take it apart. So all we need to do is we're going to mirror. And then because we know that feature mirror didn't work, I'm going to come down here to bodies to mirror. And I'm just going to use the whole body, the one body that I have for this part. I'm going to mirror that about the top plane. So I'll go to my mirror face plane, make it top. And then I want to show you all the difference between those two. So that one, so we have a nice mirrored feature. If I suppress this one and then look at the original mirror, that's how that original one looks like. So you can see that one's not really a true mirror, whereas this one here is. Does that make sense? So if you're ever having issues with mirrors and patterns, using the body mirror, body pattern options is one way of overcoming some of the feature scope limitations that you might come up with as your parts get more complicated. Does that make sense to everybody? Then I want to make sure I can do the rest of my features with that. So I'm going to unsuppress each of these. I don't want to unsuppress the mirror. Let me undo that real quick. Looks like I can't unsuppress the boss extrude. I'm going to edit this real quick. And it's just trying to use this error, this vertex here on the edge. I'm going to try and delete that. And then see if I can't get rid of the mirror. I'm going to delete the mirror, but I'm not going to delete the child features because I want to get rid of that. And then I can resolve the other errors. So in here, I've got a center line up here. I'm not sure what I'm using that center line for. Maybe I just delete it. I do probably want to specify the width of this base part. And then that resolve that one. And then I can unsuppress the lettering on both sides. And we're good to go. So a little bit of kind of an overview of looking at debugging. On there, if I can undo the changes I just did so I can do it one more time. You guys can follow along. So here I have this boss extrude 4, which is a dependent feature for my mirror. And then these other boss extrudes are dependent upon that first boss extrude, or really the fourth boss extrude. I can delete that one. The default is for it to delete all of the child features when you delete something. If I uncheck that, I can delete that. And it's just going to give me an error in this feature because there's something in that mirror that it doesn't have anymore. But I can go into the sketch on this, figure out what is giving me the error. In this case, you can see there's kind of like these, the endpoints here are kind of brown. It's missing the feature that defines that endpoint. It's got a kind of error color to it or warning color. So if I get rid of those features and then replace them with something else to fully define this part or whatever I want to add to it, I don't really need this fully defined, but I can just make it whatever I want. Then I can resolve the rest of these issues. that make sense? All right. What I really want to cover today is talking about some of the different aspects of molding and what we can do to make parts easier or harder to mold and to get those parts out of the mold and to have, less issues with voids and all those different kinds of things. The first thing that I have to do or that I have to consider when designing a mold for a system is how do I get the material into the mold cavity? And so typically you need to have a middle delivery system and a gate that goes from some kind of port outside of the mold into the mold. On this one, what I want to do is I want to try and deliver material somewhat evenly throughout the base of this part. And I can orient this however I want inside the mold cavity. And I want to try and figure out a way of designing this or orienting it so that way the gases, whatever those gases are, usually air, can escape from the mold as easily as possible. And so if I'm going to be gravity filling something, that means making sure that the part does not have ceilings or caves inside the part as we fill it up. I find the easiest way of visualizing the filling of a part from kind of a top to bottom or bottom to top is to use the section view tool. So I'm going to turn on section view. And what I'm going to do is I'm going to cut this across. Which plane do I want to use? Looks like I do want to use the front plane. I just got to do an offset here. And you can see this part. Now, if I'm going to fill this up, if I'm filling it up like that, right, as I go down, you can imagine how this is going to fill. It's going to fill like this, right? That makes sense? If I orient it the other way around, all I gotta do is flip the direction of this, and now it's going to fill like this. That make sense? So one of the things I want to watch out for here is as I fill this, you see that I have two separate cavities here. That's going to be the void space, and that's going to be the filled space as I flip it back and forth. The problem with this is as I fill this up and I go through all these little kind of feathers on the eagle, I'm going to have an air pocket inside of this kind of tip of the feather here. Oh, cancel. That is no longer connected to where the rest of the part is filling up. So even if I fill this thing from the bottom up, there's not going to be a way for that to escape. Does that make sense? If I flip this around the other direction and look at the other way around, if I'm filling this up from top to bottom, all the material is going to flow down into there. All the thing above this, that's all one piece. So now that's my void space. If I'm filling it, again, this is now the feathers pointing down as the fill direction. So my void space here is continuous throughout the entire fill volume, which means that I only have to have one or maybe two channels to allow those gases to escape. Whereas if I flip it the other way around, I'm going to have a channel for the gases to escape on each of the tips of these feathers, or I'm going to end up with air pockets at each of those points that are not going to fill in. Does that kind of make sense to everybody? So my design on this fill is to fill it in from the bottom of this part. I'm going to turn off the section view. So I'm going to fill from here, and I'm going to let the material pool at the bottom of this coming up this way. So that's where I'm going to put my gate. And that's the first thing you got to figure out. Where do you want to put the gate for the part? Does that make sense? The next thing you want to decide is how big do you want your gate to be? And if I'm doing a gravity fill, really I want my gate to be as big as possible because it's going to allow me to put in as much material as I can and the least amount of time, because the more viscous whatever material I'm trying to fill in is going to determine my fill time. If I'm injecting under pressure, I may want to control the rate of injection and restrict it in spice amount such that I don't get too much cooling of the mold too quickly. And so I may have a certain rate that I'm trying to achieve, and I can calculate that based off of the viscosity of the material, the size of the opening, and the pressure of the injection. And we're not going to get into the details of any of those calculations, but if you take fluids, you kind of understand the relationship there, right? The larger the opening, the higher the pressure, the lower the viscosity, the faster it's going to fill. So in this one, I'm going to make a very long, narrow gate along the base of this part that I can easily break off after the part has solidified. And, will look okay because it's going to be somewhat hidden along the bottom edge of the, whatever you call this, icon. So to make that, I'm just going to go to the top plane and I'm going to sketch. And I'm going to use a center point rectangle. And I'm going to put that center point rectangle, wrong spot. I'm going to start in the middle of the bottom of my part with that midpoint there. Zoom in, let me see a little better. There's the midpoint. And I'm just going to drag this not all the way across, but most of the way across the part. And I'm going to specify the width of the gate. I'm going to make it 1/2 inch wide. And I'll specify the height of the gate. And I only need to be maybe 0.05 inches tall. That makes sense? So far, so good? All right. Now I'm going to accept that. And I'll use that sketch to do a boss extrude. And I'm going to do a mid-plane extrude. And on this point, really all I care is I need to make sure it's thinner than my part because I don't want it to make a block at the bottom of my part. I want it to be like almost like a web or a hinge that I can break off after the part is solidified or cut off. So I'll make it like 0.01, something nice and thin. I did merge that. Yeah. And actually, now that I'm thinking about it, it probably would make sense to do this as a derived part. So you have your original part, and then you have your part with all of this things you're adding to make the mold. We're just going to skip that for the sake of not putting an extra step in for time. But yeah, I would suggest that you make these mold parts as a derived part from your base part. So that way you still have your original component without all the modifications. So there's my gate, and I'll kind of rename this. Just as a note that you can change whatever the names of things you want them to be, right? And the next thing I'm going to do is I'm going to design the delivery system for this. And I want to make sure I have capacity inside my delivery system to hold an amount of fluid. How much fluid? Probably something that is reasonably comparable to an appropriate volume of excess material you would want to have for your part. 10% is kind of a good amount, but you can eyeball these things. It's not super critical. You just want to make sure that you know the part is filled when you can see that that reservoir is no longer draining at an appropriate rate. So this is an overflow to make sure your part is full. Sound good? So I'm going to add that to this part. And I'm going to do this in the easiest way I know how. So I'm going to go back to the top plane. I'm going to sketch. I'm just going to draw a line across the top of my gate. And then what I'm going to do is I'm going to go into my features. Oop, say no. Hit the wrong button. Sorry. Go to swept boss base and use a circular path. With this one, I can use this line to make a cylinder or any combination of lines to make a network of cylinders. And we're going to see how this is beneficial when we duplicate this one more time. And I'll make the diameter of this 0.5 or 0.05, sorry. Again, so I'm just making a little bit of a reservoir there to serve as an overflow chamber for my gate. I can take this one step further and say, hey, if I don't want to make these one at a time, because it's not a super large part, I can make a pattern of these and then use the same delivery system for all of my parts. So I'm actually going to roll back to just my pattern with the gate. And then I'm going to use a pattern of this entire part. And I'll do it along just one of the edges here to get a direction off. And we'll make, let's do 3 of them. And what I'm going to do is I'm going to pattern the bodies. So I'm patterning the entire part. And I'll just put them far enough apart that they're not touching. You see that? Now what I can do is I can take that sweep that I made before and I can edit that feature and I can actually combine, or sorry, I need to edit the sketch. And cancel. I'm going to edit the sketch for the sweep. And I can take the endpoint here and just drag it all the way across all my parts. Now I have a delivery system for all 3 parts. That make sense? So if you want to make a tree of components, all you have to do is connect them in some reasonable way. And if you can draw the path that you want the material to flow through, then you can use that sweep with the circular profile to make round channels that go through whatever you want to do. And so this kind of goes back towards like the model airplane or any kind of plastic model design where you have that set of runners that are delivering material to all the different components that are injected and molded all at one shot, right? That sound good? The next thing we need to do is we need to have some kind of reservoir for the material or an injection point for where the material is going to enter the cavity. If we're gravity molding, then this has to be some kind of geometry that we can actually pour into. So it's got to be some kind of funnel. If it is an injection mold, then it's really just going to be like a hole somewhere that pierces the mold. And so it may just be a cylinder. Let's just see what each of those looks like. So I'm going to do another sketch on the top plane. And I'm going to make it right here. Not the best spot because it's not equally spaced, but it'll work. And I'm going to do a sweat boss base, circular profile, a little bit bigger than the last one. Actually, I needed to go that into the part. So I'm going to edit this real quick. Edit. I want this to go all the way into the line. There we go. And then I can merge these 2 bodies together. So I'm going to control click. And I'm going to combine all of these components. Do add. There you go. Now we've got one solid body. And like before, we can make our mold cavity by making a new body. I'm going to use the corner rectangle just to draw a rectangle that goes over the entire part. But I'm going to let a portion, my delivery point, go out past the edge of the volume of my extrude here. Now, in this case, I'm drawing it at the bottom. That doesn't have to be where it comes out. It could come out the side or whatever as well. It's kind of up to you where you want that to come out. So in this, what I'm going to do is I'm going to extrude this. And I'm going to use a mid-plane extrude. And I think we use a distance like 0.3. And I want to go all the way around my entire part, except for at the point where it's going to come out. Oh, I need to not combine those bodies. I'm going to unmerge the result. And then again, I'll use my subtraction to subtract those two bodies, just like we did last time. Main body is my block, and then my subtraction body is that other part. And then I'm going to split those across the top plane using just the split tool. And that's the same thing we did last time. So we'll cut, keep those two components. And then I'm just going to hide that so we can see what that looks like. So that's the same process we did last time. So this is a functional mold. I suppose what we had last time was non-functional because we had no way of delivering the material into the cavity inside the mold. This is still not what I would call a good mold because we still don't have any vents allow for the material to flow. And if we want to use this as a mold we're going to pour, then we have no way of knowing whether or not we poured enough material, and we don't have a reservoir or a cup to pour into. But we can continue to add to and modify this however we want. And again, the rollback bar is probably one of your best friends when designing the molds, because if I want to inject that component, all I got to do is I got to figure out how much volume do I need. So I can come into my evaluate tool, my mass properties, and I need a volume of 0.14 cubic inches. So if I make a volume of that size for my cup, I'll know when I have enough material poured out because it'll fill the cup with that space. So that's what I'm going to try and do is I'm going to try and make a cup that has that same volume. And I'll try and make it something close to the geometry of my part. So I'm going to go again back to the top plane, probably getting bored of the top plane at this point. And I'm just going to draw a funnel shaped rectangle that intersects where I have that part. And I'm going to make it a little bit taller than this because I want it to be something somewhat comparable in size to my other components. And we can even go so far as to line it up on the edges so that we know it's kind of close to the size of my part. And I don't have to be too specific here. I'm going to do extrude boss base. I'm going to make it a mid plane. And I'm going to say, let's start off with 0.25. And actually, I'm not going to merge that right now, because what I want to be able to do is I want to be able to evaluate the mass properties of just that body. So there's that body there. This is the mass properties of the combine. Recalculate. So there's the 1.4 cubic inches for the combined one. This is the total volume, 4.9. And then my boss extrude 8, we just do. And now we've got 0.29 cubic inches. That's for the whole thing, sorry. So 0.15 cubic inches. And then for just the eagle portion, got 1.14. So you can see that those two components, the one that I'm going to use as my cup and the one that's my final part, have the same volume. With that, now I can go and combine those two, or even I can leave them uncombined if I want to. Maybe I'll do that. Maybe I'll just lose them from the split. Inside this combine here, what I'll do is I'll include in the subtraction body, this body 9. And then I need to extend the boss extrude I have for my part to come out to the edge of that cup. So I'm just going to take this. I'm on the feature, I need to do the sketch. fit sketch. I need this edge here to line up with this edge. I'll make those collinear. And this one's going to drag out, so it's big enough. Maybe center it a little bit more. Now what I have here in this void, which maybe I want to actually call this the cup, is I have a reservoir right here at the top of my mold that is the same volume as my final part. So if I'm pouring material into this cup and the cup fills up, what does that mean? I've poured enough material. I know that if I fill that cup up, I've poured enough material into that mold. So even if it's fairly viscous, I have like the viscosity of honey, I don't have to worry about not having used enough material in that design. Does that make sense to everybody? So we've got lots of things here already. And hopefully this is making sense. We've got the original part. We've got a gate to control the flow into that part. We've got some runners, right, to allow us to deliver material to multiple parts or even just to the singular part. And then we've got a cup, which will hold some excess material if we're doing like a poured mold. Last thing we need to consider is vents. So as I fill in this component, and I'm going to go back towards before I have the, right here, you're probably going to have bubbles somewhere along the edges of this part. And you want to be able to get rid of those bubbles. They're going to be bad. They're going to prevent the mold from filling entirely. I don't want to make my mold more complicated than it needs to be. So at this point, I'm just going to put the vents on one portion of the mold and cut that out. And then I'll worry about the other side never, ever again, right? It's just going to be, it'll be done and I'm good. So what I'm going to do is I'm going to go to after I've got my cuts and I've got just one side shown, and I'm going to add places for air to be able to escape from this mold. Now, the outside ones here are pretty easy. If I look at this one, I can come in, do a sketch, and I can draw a line that goes from my outside of the mold to inside the mold. And actually, let's make it even further than that. And then go into features, extruded cut, do a thin feature. Then all I have to do is specify how big do I want this vent to be. So I'll do mid-plane. I'll say I want it to be 0.02 inches wide and 0.02 inches deep. And you can see how deep that is inside the part. And only thing I'm letting escape through here is air. So it does not need to be big, right? Air is not viscous. So it doesn't really matter. In this kind of case, if it's gravity fed, this is not going to fill super fast. So it's not going to be a problem. You would include a vent like this, even if you are doing a very, very high injection mold, but the thickness of the vent might be microns because you're injecting under very high pressure. And so that air is going to come out. And so it's more just like a scratch and a very specific location to allow flow in a specific area. In this case, I want to make my vent big enough that if I'm going to 3D print this mold, it doesn't get consumed by the 3D printer. So I might want to make it a little bit wider. Say I make it 0.8 millimeters. That's not 0.8 millimeters, right? Something like that. So I know it's more than one line width thick, right? Again, that's totally fine. That's a totally fine vent. And I'll just call this, oh, I wanted to rename it, not edit it. Just double click. Vent. So that's easy. And I can do that the same way on the other side here. But what about this middle part? How do I get a vent in there? A little more complicated, right? Because I don't have an immediate access to the outside of the mold. But I can take advantage of the fact that this is a three-dimensional geometry. Now you may say, well, why don't I just vent straight out through the top? And the problem with that is that if I vent straight out, it's going to fill with whatever my viscous fill material is, and then that will prevent the air from flowing out. So really, I need to make sure that my vent does not cross my injection pathway. So you want to be able to draw a line from wherever you're filling in through your part out to your vent that doesn't reconnect. So it's got to go all the way out. But I can put holes wherever I want. So I can put a hole right here next to the part, or I can make a line that goes from inside the part to outside the part along whatever path I want. So I might want to go and look at my top plane, or sorry, not on my right plane, and say, okay, well, that works out okay, but maybe I don't want it in the middle of the component. Maybe I want it on the sides. I'll just make a reference plane that's parallel to that top plane that connects with wherever I want my vents to be. I'm waiting for Solidworks to load here for a second. It's going to do it. I got confidence in it. Here we go. So again, parallel to the right plane. And then I can look at the second reference and I can pick a spot, say right here. And then I can use that to draw my vent in a direction that's not in line with the mold. So let's go ahead and sketch. And maybe I'll go to a hidden line view so I can see a little better what's going on here. There's the top of my mold. And I can just have this go straight out the outside of my mold. And probably, like I did with the last one, I know it's different from what we usually do, but in things like this, a lot of times it's good to actually have it go out past the end and past the beginning. So when I cut it out, it's got a little bit of extra size. And then we should be able to take that sketch and we can use that to do a sweep cut, just like we did before with a circular profile. And I can make that like my 0.8 millimeters, or whatever size I want to be. Oh no, 0.8 millimeters, not meters. It looks like that might have been a little bit too big. But you can see I've got a vent now that comes out. It intersects my other vent, so that is too big. Let's just do it a little bit smaller. So it's 0.02. There you go. And now I've got another vent that does not intersect my main part based off of that. That makes sense? So we can have those vents go in whatever direction we want. And most of the time, they're going to be able to come out. The last thing that you want to include in your mold, a lot of things, I know, is you usually want to have some kind of locating features for both halves of the mold. In this case, you could say that the locating features of the mold are the mold itself, and that the edges of the mold just line up square, and that's what I'm using to locate them. But more often than not, you want some kind of intentionally designed locating feature that's going to help the alignment of those parts as you've made them. And so with that, you want to typically add some kind of peg and some kind of slot or hole inside the components. So if I'm going to do that, again, I'm going to hide this outer portion first. And I'm going to add a peg to somewhere on this mold, and probably at 2 locations. We'll make them the same size. So I'm just going to come over here. I'll do one at this top right corner and one at this bottom left corner. And I'm just going to say that these pegs are 0.1 inches in diameter. I like that, okay. And really, I want to locate them. So probably I should say that they have some spacing from the sides. So let's say 0.2 in. That might be too close to the part. And let's just use 0.1 for everything. 0.1, 0.1, 0.1, 0.1. All 1/10 of an inch. And I don't really care where this is, as long as I can make it at the same spot each time. It does bother me that those dimensions overlap though. Right, so there's my pegs. What I'm gonna do is I'm gonna use that same sketch for both sides, but we'll offset it to get the whole side. So we'll build in some clearance here. So what I'm gonna do is I'm gonna do my sketch. I'm gonna do another set of circles. Actually, let's do it in a separate sketch. We'll do it as a separate sketch. So I'm gonna accept that sketch. I'm gonna do another sketch on the same plane. What I'm gonna do is I'm gonna offset both of these circles by some very small number. So 0, 1, just a clearance offset. It's like I can't do both of them at the same time. Can't, I gotta do them one at a time. So let's do offset, we'll do 1, accept, offset, the other one, accept. And then I'm gonna use this outer set of circles to do a cut extrude, features, extruded cut, and I'm gonna taper it. So let's give it a 2-degree taper. Let's do a little more schematic. We'll do 5-degree taper. And this one, I'm just going to have it go through all. And then the first one, I'm going to do a boss extrude with that. I'm going to use the same 5-degree taper. And this one, I'm just going to have it go up to the top surface here. And because I did the cut first, I should still have 2 bodies. I don't. Didn't like that. Here's what we'll do edit. Feature scope. No, I just don't want to include that secondary body. Is the right one? There we go. And now what I have is one side of the mold with locating pins and my vents. And then I have the other side of the mold, which has locating holes, right? And just the negative side of my part. And then that's what I would consider to be a complete mold, where I have the void that I want. I've got gates, I've got a delivery system, I've got a storage system, I've got vents, and I've got locating features. Your project 3 is to make a mold for one of your parts. And I'm going to look to see, does your mold have all of those features? So it has some kind of void that is an appropriate geometry for what you're trying to make, and doesn't have, a bunch of overhangs that's going to prevent you from separating those 2 parts apart. And you can make it more than 2 parts if you want. If you want to make a 3-part mold or a 4-part mold, that's okay. Does it have some way of getting the material into that void? So some kind of a gate that's a controlled size. Doesn't have to be, you can be any geometry you want. So the gate can be circular, rectangular, whatever, but you should have some way of controlling the size of the cross section of that gate. It can just be the thickness of the extrude. Some kind of delivery system, so that way you can get the material into the part. Some vents that make sense based off the locations and the directions of your delivery, and then some kind of locating feature. Okay. And this is being recorded, so you can go back and you can watch that list of things again if you want. Anyone have any questions? Does all of that make sense to everyone? Kind of. Okay. Yeah. Sorry if that was a little bit fast. We got a little bit of a late start today. And I wanted to make sure we got all that in before the end of class time.